I'm asked to find the domain and range of this piecewise function, and it looks fairly complicated, and that's because it is. You'll want to do these nice and slow. I find it's going to be a lot easier if we can focus on what these graphs look like. The part here on the left-hand side, an x squared, we're kind of familiar with that, a negative x squared, and a negative x. So I'm going to bring in the graphs of all three of these. X squared is right here. Negative x squared is pretty much the same thing, except for instead of a smiley face, it's now a frowny face. And then here's our graph of negative x. Now let's bring in our main graph that we're going to use here to graph all of these. The main components here, it says if x is less than negative 1, then it looks like the x squared. So negative 1 is where this particular graph starts. What I'm going to do is I'm going to draw a line, just kind of a dotted line right down to negative 1. That'll kind of help me to view it of where my graph of x squared is to stop. Now this actually isn't going to be part of the graph. I'll erase it later. I'll show you that. But anyway, in between negative 1 and 2 is the next portion. So this one's going to look like our negative x squared. So I'm going to draw another line right here at 2. That way anything in between here is going to look like my negative x squared. And finally, greater than 3. So I need another blue line right here at 3. Okay, well now that I have these kind of sectioned off, if you can envision the x squared here, it just kind of looks like this smiley face. So if we brought that over to this graph here, it would kind of start right here and go all the way down, hit the x-intercept, and bounce right back up and keep going in this direction. Now, the difference here is that we don't want to see the entire graph here. We only want to see what's less than negative 1. So I don't want to show the rest of this here because that's greater than negative 1. So I bring that one in now, and it goes up, and notice how it has an arrow indicating that it continues on. Now, it's going to continue on both up and to the left, infinitely. So that's going to be important when we get to that part. Okay, but here's just that one sneak peek portion, if you will, anything that's less than negative 1. For our negative x squared, it looks like this, and it says it in between negative 1 and 2. So I look over here at my graph. Here's my negative 1, and here's my 2. So it's going to look like this. It's going to come all the way down until it hits 2, and then pretty much stop. So on this one here, we'll bring that one in. There's our negative 1 all the way down to 2, and then it stops. Notice there are no arrows on this one. This one does not continue on. It stops right there at 2. Okay, and then finally, and I don't have anything in between here, not according to what this says. So finally, I've got one that's x is greater than or equal to 3. And that's going to look like, now we go over here to 3, 1, 2, 3. So we're going to have just this little tail end portion is all we're going to have over here. And there it is. Okay, so we've got that, the rough graph done on it. Now let's talk about this. This one says it's less than negative 1, not less than or equal to. So in other words, if the x value is negative 1, it's not going to be on this first graph. The way that we'll indicate that when we graph it is by an open circle. So we'll take and we'll put an open circle right there. Now notice on this one, this is negative 1 is less than or equal to. Here's our or equal to. Because of that, this one is included. So if x equals 1 in this case, we're going to use this graph. We're not going to use this one. So in order to indicate that, we don't do an open circle, we do a closed circle. So it'll be a closed circle right here. All right, and then we've got less than 2, so down here, and again, this one is less than, not equal to. So we're going to use our open circle again. Finally, we have greater than or equal to 3, so we'll use a closed circle on that. So if x equals 3, it is on this graph here. All right, now let me get rid of those blue lines. We don't need those anymore. There we go. Okay, same graph right here, but this is what your piecewise function would look like. Now that we know this, we know we can use it to find the domain and range. Remember, the domain are all of our x values, all the way across. What kind of x values do we have? In order to do that, what I do is I go ahead and start. Well, I start over here. And while it doesn't look like we have anything on this side, remember that this one here, our x squared, keeps going up and to the left, up and to the left. Keeps going up and to the left infinitely. So we do have an x value there, so that does work. So we write negative infinity. And we use the parentheses all the time with infinity. We never use brackets, just parentheses. Now what I do is I kind of like envision this as a pen. I'm just dragging it across. And I want to see everywhere that it intersects x values. It's intersecting everywhere here, everywhere here. Right here it gets a little bit tricky because it does not intersect right here. However, at negative 1, it does intersect over here. So we're still okay. So we're still going. We keep going all the way till we hit 2. 2 is where we stop. And we've got an open circle here indicating 2 is not included in this data set for x values. So we're going to close our parenthesis of 2. Okay, but we can see that it continues on here. That means we're going to keep going across here. We don't have any x values here in between 2 and 3 since there are no x values. But we know it does continue. 3 is included in the data set. Now notice I have a parenthesis here for 2. 2 is not included in the data set, so we use parentheses. 3, however, is included in the data set, so we're going to use a bracket instead. And as we go across, all of these are x values infinitely, all the way across here. This is going to continue to go down and to the right, down and to the right, all the time. So that's going to give us our positive infinity. So this is your domain on this one. And again, open parentheses indicates that it is not included in the data set. Close parentheses indicates that it is included in the data set. We can look up here. X is greater than or equal to. So this one is included, whereas 2 is not. All right, let's bring in our range. Range, again, is our y values. So I do the same thing. I just bring a line here. Okay, I can see down here that we've got negative infinity because it'll continue on. This line here, remember, goes down and to the right. So we've got negative infinity. And I'm just going to kind of drag it up. As I drag it up, it intersects everywhere, all of these y values, up until I hit here. Now when I hit here, I hit right here, and it does intersect right there. That is 0, 0. Y value, there is a y value there. It is 0. This is our negative x squared. If x equals 0, y equals 0 as well. So because it is included in our data set, we're going to use our brackets again. So I use my bracket here of 0. And while there aren't any in between here, I do know that there's going to be some more, so that's when we use this symbol here. This means that we're going to include more of them. Let's see what that looks like. See, we don't have any in between here, but then right here we start again. This looks like a positive 1, but it is an open circle. Because of the open circle, that means that it's not going to be included in our data set, so we're going to use an open parenthesis. And then as we continue to drag this line up, it intersects everywhere there. That's our positive infinity. So this is our range. The biggest thing that you need to be aware of here, kind of some rules that work all the time, are if we're going to use infinity, we use parentheses. Okay, if it's not, or if it is included in the data set, we use brackets. And if it's not included in the data set, we use parentheses. Infinity, we use parentheses because we never do actually reach infinity. So that's why we just use parentheses for that one. But if you just use it all the time, anytime you use infinity, just use parentheses, you'll be fine.